In order to maintain a constant flow of electrons through a wire or conductor, a constant electrical pressure must be applied. This pressure, or force, is known as electromotive force, the force that moves electrons, and is abbreviated as EMF. The element that supplied the electromotive force is called a source, and may be a generator, a battery, or another electrical circuit. Let's examine a battery as a source of EMF. At the negative terminal, there is an excess of electrons. At the positive terminal, there's a deficiency of electrons. The excess electrons at the negative terminal are attracted to the electron-deficient positive terminal. When there's an electrical path, electrons will flow through the circuit toward the positive terminal. Electrons are forced to flow because there is a potential energy difference between the two terminals of a battery. EMF is often referred to as voltage. Voltage is not an electrical force. It's the measure of potential energy between 2 points in an electrical circuit, and it's abbreviated with the capital letter E. The unit of measurement of potential energy, or potential difference, is the volt, abbreviated by the capital letter V in honor of Alessandro Volta. 1 volt is the potential difference that will cause 1 unit of electrical energy to move a coulomb of charge from a negative point to a positive point in a circuit. The basic unit of electrical energy is the joule, abbreviated as J. Therefore, volts equals joules divided by coulombs. In symbols, that would be V equals J over C. Examples of some typical voltages you will work with are 1.5 volts for a flashlight cell, 6 volts for a lantern battery, and 12 volts for an automotive battery. The voltage that's present at one of your home's outlets will be 120 volts, while 208 volts is used for industry. So far, we've covered 2 of the 3 properties of electricity, current and voltage. The third property is resistance. Resistance is the opposition to electron flow through a material. The resistance symbol is the capital letter R, or the Greek symbol omega. Since current flow is the movement of free electrons through a material, the number of free electrons that are in a material determines its resistance. A material with few free electrons has a high resistance. A material with many free electrons has a low resistance. Examples of materials with low resistance are copper, silver, and aluminum. They're known as good conductors of electricity. Examples of material with high resistance are rubber, porcelain, paper, cardboard, and bakelite. They're known as insulators. The ohm is the unit of measurement of resistance. It's named in honor of the German scientist George S. Ohm. The Greek letter omega is the symbol rather than the capital letter O, which might be mistaken for a 0. Therefore, 10 ohms of resistance is written as R equals 10 ohms, with the Greek letter omega used as the symbol. 1 ohm is defined as that amount of resistance that will allow 1 volt to cause 1 ampere of current to flow in a circuit. So in symbols, R equals V over A, or ohms equals volts over amperes.